So again, good evening, everybody, and welcome to our webinars on the summer 2022 outlook and a little talk about windy days. I'm Joe Delicarpini, the Science and Operations Officer. Rob Megany was going to be with us tonight, but he helped me put the presentation together, so I thank Rob for his help in advance. So let's get started talking about a normal summer. And remember, normals are simply a 30-year average. So right now, the period we're comparing it to is 1991 to 2020. And these averages, kind of include all the extremes, year-to-year variations, normal parts of the climate cycle, things like, climate change as well. But the thing to remember about here in the Northeast, our weather patterns occur in cycles, usually several weeks at a time. I think most of you will know that happens over the winter. We tend to have our winters compressed into almost a 6-week period. Lately, it seems to be like late January through early March. So we tend to see the similar thing in the summertime. It's just less noticeable because we're not looking at snow, but we can have hot and dry periods and cooler and wet periods as well. The rainfall does tend to be more localized in the summer. I think that makes sense. We're usually, seeing showers and thunderstorms, not these big low pressure systems moving through. So as we go through, I'm going to just take a quick look at last summer as a little review. And certainly the theme was above average temperatures and above average rainfall. So kind of on the warm and wet side. So we'll go through our climate sites, and we'll start with Boston. This is a look at temperatures over the entire summer, and for climatological purposes, we define summer as the months of June, July, and August. So the mean temperature was 74.5 degrees, and that takes all of the high temperatures and all the low temperatures for each day and combines them into one average for the day. So on this chart, you can see the day-to-day temperatures, the highs and lows by these blue bars. And you can see we had some, hot periods in early June, also some cooler periods interspersed. Seems like, almost a little more below the curve. And this is the normal range in the middle. So you're looking at the record high temperatures up at the top, and in the blue, the record low temperatures in the bottom. So notice we're certainly closer to the record highs in these blue bars than we are with the record lows. There's a few cool mornings here in early July, but for the most part, near or above average temperatures in Boston. Let's take a look. Providence, a similar theme here. You'll see a lot of the temperatures are skewed near normal, even a little bit above, but definitely some cooler periods here in later July and early August. I think there was some cooler weather at that point. Didn't really affect Boston as much, but again, above average, not quite as much as Boston. 73.5 degrees was our mean temperature for Providence, and just above the normal of 71.9. So going through Hartford, a little bit warmer, which makes sense. It's an inland site, but a lot more extremes too. Notice we've got, early June, we have almost a record low temperature there in the 40s. A few more of these dips occurring throughout June and even into July, and also a few reaching up near the high temperature records. So, the early part of June, the end of June. But for the most part, you can see, pretty much somewhere in that normal range, which is this kind of light brown shading. Not a lot of variation from that. And then for Worcester as well, notice a similar theme. Again, mostly in the normal area, but a little bit above. It was a couple of degrees above normal for the summer. A few higher temperature days here in early June. Some cooler ones as well later in the month and also into early or later July. Down here, no record lows and doesn't look like any record highs occurred. Looks like we tied maybe one day here at the end of June. But for the most part, it was a warm summer across all of our climate sites. Now let's take a look at rainfall, and I've got a few different curves here to show you. So first of all, the green line is the actual rainfall for 2021. The normal is kind of the brown line here that slopes kind of from left to right. And then I also added the wettest years in the blue and the lowest years in the red. So you can see for Boston, 1955, that was a big tropical year. So you can see that's definitely goes above. We were actually running ahead of that for much of the summer until the August timeframe, which is when the tropical systems hit in 1955. And then the lowest year was the drought year of 2016. You can see very little, if any, rainfall right through the entire summer. We started out near normal, but then quickly dried out. Whereas this past summer, it was fairly dry throughout June, then a quick jump up in early July, and we stayed kind of wet. If you remember, there were a lot of showers and thunderstorms around. We had a couple of tropical systems in August, so that put us ahead of the curve for the rest of the summer. And you'll see kind of a similar theme here as well at Providence. Again, the the record year was 1922, so a little bit earlier, but you can see starting out below average, our green curve is below the brown, then kind of catches up in early July, and then we stayed above that for the rest of the summer. Again, a lot of showers and thunderstorms through July, and then our tropical activity as we got into August. And the lowest was 1907, so different years than Boston, but again, it was pretty dry in 1907. Looking at the inland sites, also above average. You can see again, starting off below normal throughout much of June, and then we turn the calendar to July and we kind of take off a little bit, go above normal, and stay there for the rest of the summer. As with Boston, the highest was in 1955, thanks to our tropical systems, and the lowest was actually in 2020 in Hartford. So that beat out 2016, but still was fairly dry across the interior. There were not many days of showers and thunderstorms back in 2020. And then rounding it out for Worcester, just to show, again, a little bit later onset of the showers and thunderstorms, a little bit later into the first week of July, but then stayed above. Highest was 1955. Again, probably no surprise to those of you who remember the big tropical days. And the lowest was 1929. So that's shown here by the red curve. So again, the theme for last summer, warm and wet, especially once we get into July and August. And usually in the summertime, it's the tropical systems that bring us our big rainfalls. Okay, so what about this summer? Are we going to be hot and dry? Are we going to be cold and rainy? Something in between? So we'll go through some of the data here and see what we can figure out. So the first thing I want to explain is how the atmosphere kind of works. I remember back in college, we talked about this quite a bit. So in the wintertime, the atmosphere is in what's called dynamic mode. So that means you're dealing with more dynamics, essentially from the jet stream. So obviously in the winter, we have greater temperature contrasts in the northern hemisphere from north to south. We've got a lot of cold air masses. Once in a while, you get some warmer air trying to work in, but you also have things like the Gulf Stream at play with warmer ocean temperatures. So as a result of all that, the jet stream is typically stronger in the winter than it is in the summer. And this provides a lot more energy for weather systems to develop and even strengthen. So that's why we get our big nor'easters, our bomb cyclones, as we like to call them, in the wintertime. It's a result of a stronger jet stream, stronger temperature contrasts. And as a result, the global circulations are more dominant. So think about things like El Nino and La Nina. They have more of an influence in the winter than they do in the summer. So let's flip the coin now into the summer. We're in what's called thermal mode. So there's less of a temperature gradient from north to south. Overall, the jet stream tends to be weaker, but if you've seen some of our big severe weather case studies, there are days where the jet stream can be pretty strong, and those are usually our big severe weather days. But the primary driver for weather systems is a process called convection, and I'll review that in a second. And as a result of the weaker flow, the less contrast in temperature, the global circulations are less dominant. So just to review convection, remember it's rising air that rises, condenses, and forms clouds and showers and thunderstorms. And also our tropical systems are the results of convection. They're called warm core systems. So they're purely the result of what's organized convection. So when we talk about an unstable atmosphere, it's like on the left, we have warm air below, cool air above. The warm air rises, mixes with the cool air, and causes everything to become unstable. Whereas when you have a stable atmosphere, you have cool air near the surface and warm air aloft. So this is kind of like a nighttime situation. And the air can't mix around and develop usually like showers and thunderstorms. We call this a lot of times diurnal heating. It's heating from the sun during the day, and it kind of eases at night. So an example is, most of our thunderstorms occur during the afternoon and the evening during the time of peak heating. And in most cases, the thunderstorms weaken with sunset because we're starting to lose our daytime heating and our convection. So this is the primary driver now as we get into the summer. So as a result, it's a lot harder to predict a true summer outlook as opposed to a winter outlook. There's fewer factors here at play. But we'll talk about, the El Nino, La Nina influence. That's kind of the primary one that's going to continue through the winter. And again, just to review some of these, we've covered these in our winter outlooks, and they certainly come into play more in the winter. Things like the El Nino, La Nina, something called the Mad and Julian oscillation, which has to do with thunderstorms over the Western Pacific and over the Indian Ocean. But in our part of the globe, what we call the mid and high latitudes, so think like areas around 40 north-ish, we have the Arctic oscillation and North Atlantic oscillation, which are pressure differences between Greenland and the Azores. Also, the Pacific North American pattern, which is kind of the jet stream configuration across North America, and the Eastern Pacific Oscillation, which is similar to the AO and the NAO, but it's over the Pacific. So on the left, these tend to be less of an influence because we have weaker weather systems for the most part. So, we can look at things like the NAO and see if it goes negative and see if we're going to get a trough in the east or blocking over Greenland. But overall, it really doesn't have as much of an impact, aside from bringing maybe more widespread showers and thunderstorms. So we'll talk a little bit about El Nino and La Nina here. And for the summer 2022, the latest indications are these La Nina conditions will continue. So just as a brief review, La Nina up here at the top refers to the cooler sea surface temperature anomalies or differences off the coast of South America. When they're below average on the top, it's a La Nina. And on the flip side, when it's above average, it's called an El Nino. So the name actually originated from the Peruvian fishermen in the 19th century when they noticed the difference in fishing from the La Nina to the El Nino. So these are oceanic patterns, but they do have a connection with the atmosphere. There's ocean to air connection that makes sense. So it also is able to drive the jet stream over large parts of the country. So the Climate Prediction Center is continuing what we call La Nina advisory. There's a 60% chance it's going to continue through the summer. So, still a chance it won't, but the odds are favoring it will, and likely into the fall as well. So, 55% chance that we'll continue to see these cooler than average waters off the west coast of South America. Okay, so what does this mean for us? Well, during the summer, as I mentioned, has less of an effect on our temperatures and precipitation over the United States than during most of the winter. So note when we get into the summer, which is down here at the bottom, really not much of you can see much of an influence at all. All the influences here are closer to the tropics, the equatorial regions, the Indian Ocean, the Western Pacific. And this is where most of the convection is occurring, as opposed to the far northern or far southern latitudes. But in the southern hemisphere, remember, we're going into winter. So the correlation is a little bit stronger down here, places like Australia, South America, whereas in the wintertime, note how the impacts are more near the equator and points north, including North America. So overall, there's very little correlation with La Nina and our weather patterns here in the Northeast. A little more so during the winter, but even that, it's a pretty weak signal. But summertime, it's virtually no influence at all. But the one thing it does impact is the hurricane season. So over the Atlantic, La Nina tends to favor more hurricanes, more tropical cyclones, due to weaker vertical wind shear and the weaker trade winds. So what does that mean? Remember, vertical wind shear is the change of wind direction with height. So if you have stronger wind shear, these thunderstorms are not going to be able to organize. They're going to get ripped apart. So if you want to have a hurricane, you want to have weaker vertical wind shear. And that will support, again, with the La Nina influence, more hurricanes over the Atlantic basin. Now notice the opposite is true in the Pacific. In the Pacific during La Nina, there's greater vertical wind shear, greater stability as opposed to instability. So this supports fewer tropical cyclones across the Pacific basin. So much like last year, we think much of the activity for hurricanes will be over the Atlantic as opposed to the Pacific. Not to say they're going to get nothing in the Pacific, they will, but certainly fewer than average are expected during a typical La Nina season. So we'll cover a little bit more of that in our hurricane outlook as we get into June. But just a little preview. That's kind of the main influence for El Nino and La Nina. So basically, the outlook looks like this from the Climate Prediction Center. Warmer than average temperatures across most of the country. Notice, and I always tell people, look at the odds. So, look where the highest odds are. Certainly they are across the Rockies. We're looking at close to a 70 to 80% chance of above average temperatures. And, still above average, and especially here in the Northeast, a little less so than the Rockies. But, odds are favoring above average temperatures. Now, keep in mind, this isn't the official summer outlook. This is the latest one from April. So NOAA will update this a little bit later this month. But right now, it's looking like a warm summer again. It doesn't mean we can't have cool periods. We can. It means that the average temperature, again, taking that daily high, daily low over the 3-month period, is expected to average above normal. So, regarding heat waves, remains, 90-degree days kind of remains to be seen. But overall, we're expecting above average temperatures for this summer. Now, precipitation, a little bit less of a signal here. Odds slightly favoring above average rainfall here in southern New England. Notice the focus is more down to our south across the mid-Atlantic, but we're kind of on the edges. And certainly a stronger signal for below average precipitation across much of the northern Rockies and into the plains. And elsewhere where it says equal chances, there's really nothing in the pattern to say it's going to be wet or drier than average. So, to me, this is kind of saying we're looking at more, maybe a little bit of tropical activity. There's a signal here, but hard to tell, over the 3-month period. So slight chance that we'll be featuring above average rainfall. And again, this doesn't mean it's going to be a wet summer with rain just about every day. It means, we could have a busy tropical season. We get all our rain in August, and we could have dry conditions in July. It's just going to average out over those 90 days, perhaps being a little bit above normal. Now, the one important part of this is for drought, and you'll see this is our drought outlook. And I'll include a little bit more of this in our briefing. We are actually in some getting into some abnormally dry conditions in parts of eastern Massachusetts right now. But you can see certainly the focus for drought persisting is across the western third of the country, from California into the Rockies, into Texas as well. So these are areas, that there's definitely a good signal for dry weather. Drought will persist also on the eastern side of the Rockies and the plains, but some improvement is possible. But that's really going to be the focus, I think, for the dry weather. We'll be out in the western 2/3 of the country over this summer. Perhaps we could get into some short-term drought conditions here in the east as well. It tends to happen almost every summer. We get into a dry period of 1 or 2 weeks, kind of like we're in now. But overall, not looking at a sustained dry pattern for the summer. Okay, so with that, I'm going to pause here and just see if we have any questions, and then we'll get on to our next part, which is all about the wind. So let's see if I can just answer a few questions here. So from John, is there any truth to the belief that true spring weather and fall weather is decreasing and cold winter weather and hot summer weather is increasing? Well, for the first thing, it's definitely getting a little bit warmer. We're in a warmer period, and I'm not going to debate the human-induced climate change part, but the research shows there is something to that, and I'm sure part of the Earth's natural cycle fits into that as well. What I'm seeing, John, and this is just kind of me and others at the office. It's kind of almost we're seeing a seasonal shift a little bit. So it's like we're shifting our warmer weather a little bit later in the year. Whereas, it's nice now into September, October, sometimes even November. And we're holding off the cold and the snow a little bit later in the winter, too. As I mentioned, it's more January, February, early March, instead of, right in around December for the snow. We see it once in a while, but it seems lately the true core of the winter is January, February, and early March. And our springs, a toss-up. Here in eastern Massachusetts, we get a lot of influence from the ocean. We get a lot of days of onshore flow, and it's kind of cool. But this spring has been kind of mild here in eastern Massachusetts. The interior, is typically milder because less of an influence from the ocean. So, there is some evidence that the winters are getting warmer, but we are seeing more extremes too. Not seeing as many record lows in the winter, but seeing cold shots that don't last as long. So, and we saw that this winter too. A couple of days of really cold weather, and then it's kind of back to normal or above average. So. The number of 90-degree days has been climbing at our climate sites slowly, and that is expected to continue as well. So, it's whether it's I'm sure it has to do again with the Earth's own climate cycle because things go in cycles. Also, some human impact as well. How much of each I couldn't tell you, but yeah, that's certainly there is some truth to that, John. And it's just going to have to look at the climate data and keep studying that to kind of see. The true trends over 20, 30, 40 years. And just a follow up from John, how did our latest 30-year summer average compare to the previous? A little bit warmer, as you would expect. I don't know offhand what that exactly was, but all the climate sites were a little bit warmer and a little bit wetter too. So yeah, and don't forget, now we're starting with the baseline that's warmer and wetter, so that's going to affect some of the departures from normal. So from Wayne, and a similar question here, we're talking about weeks of, cycles of weeks of similar weather. That's how the jet stream kind of operates, and I think it's definitely more noticeable in the wintertime where we get into these patterns where it's, maybe cold and dry, and then we get into a stormy pattern, and then we maybe get into a warm, wet pattern. It just really has to do with the flow in the upper atmosphere, whether there's blocking over Greenland, which is going to favor us for more stormy weather here in the east. Whether it's more of what we call a zonal flow, east to west, that gives us excuse me, Pacific air and keeps us kind of mild. So it really just kind of depends. That's just the way the atmosphere works. It works in cycles. There's a lot of different kinds of cycles in nature, the water cycle, for example. And this is just one of the longer cycles that takes, kind of runs over different weeks. So I hope that helps explain it. And here's another question from Wayne. Do long-term summer outlooks take into account sea breezes along the coast? Yeah, because that's kind of accounted into the normal. So we don't really have a count of sea breeze days, but certainly the cooling from the sea breezes, Boston, for example, Providence, would be taken into account for that as well. So they, tend to really not offset temperatures too much, but early in the season they certainly can. So like an April day in Boston could be in the 40s, whereas at Hartford they could be well into the 60s. From John, would the warmer signal indicate the precipitation may be more in the form of thunderstorms? Hard to say. It certainly favors that because if you have more warm air, you have more energy and then therefore more thunderstorms. But again, those are fairly localized and really can't necessarily be predicted on a larger scale like that. But certainly you've got the warm, the warm air that certainly favors thunderstorm days, also favors, tropical activity because remember, more warm days, that warms up the ocean. So if you have warm sea surface temperatures offshore, that allows these storms to maintain their strength as they come up the coast. So that's a kind of a we'll see one. From Brian, how does the WPC create these seasonal outlooks? Are they looking at the long-term models in conjunction with other factors? Yeah. So they're looking at a lot of the global patterns. I talked about El Nino, La Nina, that's one of them, but there are many, many of them, and they all kind of work intricately together. It's a very, very kind of complicated relationship. So they look at that. They do look at long-term models. There's something called the CFS, which is the climate forecast system, and that's kind of a version of the GFS that runs at longer time ranges. So they look at that. Also, the European model has climate data. The UK Met model has long-term data. So it's pretty much in the form of probabilistic or ensemble data that far out. But yeah, they kind of look at all the above, a little bit of intuition, I think, based on past experience. And that's how they come out with the forecast. But it's a very, very complicated thing, and it's done. Remember, these are done on a very large scale, so it's not like the scale of Massachusetts, Rhode Island, Connecticut. It's done on the scale of the United States or North America, where you can't really get into a lot of detail at those longer time ranges. And a question from Tom: do thunderstorm numbers skew towards a warmer, cooler, or average summers? It depends. I mean, thunderstorms definitely, could have effect on temperatures. But for the most part, you're dealing with thunderstorm days when you're hot and humid. So the high temperatures are going to occur before the storms do. But they can have some slight impact, keeping a little bit cooler during the day. Maybe some clouds blow off some storms across New York State and keep us cooler, could keep us warmer at night as well. So I'm sure it does have some local influence, maybe a small one, but certainly I think there is some influence there. For Fred, let's see, are the ocean temperatures cooler than average at this point in the season? Yeah, Fred, I think they are. I was looking the other day, we're into the middle of May, so they're probably near or even a little bit below. I think they're still in the 40s and even low 50s, which is pretty chilly. So, not too far off from the normal. We should start to see them really start to warm up as we get into June, especially, we should be in the low to mid 60s by mid to late June and then, warming up from there. But yeah, it seems it's been, despite the overall warm weather, it hasn't been really, prolonged warmth to really warm up the oceans yet. So we'll see. Maybe this upcoming weekend we've got some hot weather coming in that can get it started. But at this point, average, maybe a little bit below average. But there's certainly plenty of time to get those water temps going. And let's see, a last one here from Tom. Has thunderstorm severity changed in recent summers? And that's one that's really to be determined, Tom, but a good question. Are we seeing, more severe weather? It's kind of a balance. We're not really sure. We definitely have more severe thunderstorm events. And, part of that might just be we have more reports. We have more people on social media with cell phones. So we know about more events than we did even 10 years ago. So the count is up. The severity, hard to say. We do have more tornadoes, but again, I think that goes back to just more documentation of them when, 10, 20 years ago, we just heard it as wind damage, and that was the end of that. But, there's been the research I've seen from NOAA does not show any increase in the number of tornadoes or severity, but it's still very early in that research process. So they really need to look at, several decades of data before any definitive conclusions can be made. Kind of the same with the severe thunderstorms. But, my guess is we're probably seeing some stronger storms based on the warmer atmosphere and a more humid atmosphere. So jury is out on that one, Tom. And let's see, from Sebastian, we'll add one more here. Seems the past 2 years, the squall line systems tend to be more dominant than true supercell outbreaks. Yeah, I mean, those are really the most common type of severe weather we see here are the squall line systems, believe it or not. We do get some what are called pulse days, or those individual, garden variety type storms. But a lot of times they'll kind of merge into each other, form small bows or lines. And then in some cases, we get these larger lines come through like we did, October of, I think it was 2020 and May of 2020. But we do, supercells are pretty rare here, the true mid-plane supercells. Not that we don't see them, but they're certainly the most rare of the different thunderstorm types that we've seen. We've had a couple of good, like I mentioned, good squall lines come through spring, fall. Even that, last November, the tornado outbreak, that was a good squall line coming through. So, kind of dependent on how strong the jet stream is and how much the instability is. But yeah, we're certainly in a little bit more of a pattern where we're seeing those more organized lines come through than we probably have in the past, 10, 20 years. So good observation. All right. So if you think of anything else, go ahead and throw it in the question box. But we'll move on to the next section since, I didn't want to make it too short a webinar tonight. I got a question from one of our, regulars saying, has it become more windy, recently? And, I've had even people at home comment to me, boy, it's been windy the past few years. The springtime, March, April have been really, really windy. Kind of what's going on? And I took a look. Bill Leatham, who manages our climate program at the office, helped me look through some of this. Is this just a perceived trend? Is this something we've just kind of noticing, or is there something really to it? I mean, I always remember as a kid, March was the kite flying month, and everyone, go fly your kites in March. It's always windy. So, is this something real? We'll take a look at some of the data, but first let's talk about. We'll do a little bit of education. So let's talk about how the strong winds occur, and then we'll take a look at some climate data. So let's talk about some strong winds here. So the basics for wind, remember, air flows from high to low pressure, and wind is simply air in motion relative to the Earth's surface. So in our northern hemisphere, United States, the air goes clockwise around high pressure, counterclockwise around low pressure. So the air is always going to flow from the high to the low. Now, this has to do something called the pressure gradient force. So the more the pressure changes over a given distance, the stronger the winds. So on the weather map, you're going to look at the isobars, which are the lines of constant pressure. The wind is stronger where the isobars are more compact, and the winds are weaker where they're farther apart. So the higher pressure gradient is a stronger wind speed. And this comes into play typically in the wintertime when we talk about our big coastal storms, but also in the summertime when we have a strong cold front come through. The pressure gradient usually changes quite a bit. So that's what you want to look for on the weather map. That's one way that we get stronger wind speeds. So this weather map here shows an example. You can see in the yellow areas that are highlighted, you've got a pretty tight pressure gradient, a lot of isobars over a small area. So this is indicating where the stronger winds are occurring. Whereas down here near the Gulf Coast, notice there's not many isobars, maybe 3 over a pretty large area. So this is indicating where you have lighter winds. So this is a quick way to kind of look at a weather map and figure out, where the winds are strong and where they're rather weak. So summertime now, we're going to transition to weaker pressure gradients, fewer isobars, and typically lighter winds. Of course, outside of our tropical systems. All right, so now let's talk about wind gusts. And here's the official government National Weather Service definition. So these are rapid fluctuations in the wind speed with a variation of 10 knots or more, that's about 12 miles an hour, between the peaks and the lulls. And the speed of the gust will be the maximum instantaneous wind speed. So here on the right, I have a wind chart. This is actually one of the ones at Blue Hill, but these were very common in the Weather Service when I started my career, and we did manual observations. There's a gust recorder, and it simply traces with a pen over time showing the gusts, and you can easily pick out the peak gust for the day that's occurred. But sampling time varies, and this is what we're running into these days now. In the old days, it was just equipment in airports measuring wind speed. That was about it. But today we have all different sorts of data sets. I'm sure many of you know about ASOS. So now the ASOS sampling time is a 5-second gust, or in some cases a 3-second gust, but I believe it's 5 seconds now. But then you have home weather stations, and a lot of these report online, and they come into our systems in the Weather Service too. You have ones that sample instantaneous, you have 2-second gusts, 3-second gusts, or 5-second gusts. So this is why when we get into a big wind event, and this time of year, it's most notably, it could be winter storms, but also in tropical systems, you'll see a wide variety of gusts. Places like Cape Cod, you'll see someone reports a 90-mile-an-hour gust. Well, maybe that's an instantaneous, and it's another one's sampling 3 seconds, and it's maybe 85 miles per hour. So this is what we're dealing with these days, and we do our best to kind of quality controlling and looking at things like sighting of the instruments, make sure it's in a reasonable area. But the difference in sampling time also will affect the speed of gusts. This is just kind of an aside when we talk about wind speeds. So how do the gusts occur? What we call something the mixed layer. That's the depth to which the atmosphere can mix, and this is what affects the strength of our wind gusts. So in the morning or nighttime, we tend to have an inversion. So the mixing layer is pretty much gone. But during the daytime, as the sun heats up the atmosphere, the mixing layer gets deeper and deeper. It can get up to 5,000 feet, 6, 7, 8,000 feet sometimes. And the higher the mixing layer, the higher those winds can mix down at that level. So it all has to do with just kind of mixing all of this down. And think of it as almost like turbulence or a turbulent flow. So again, on the left, you have a stable layer. There's not a lot of mixing. There's maybe an inversion, which we've talked about before, which is temperatures increasing with height. That's called a stable atmosphere. But during the day, and especially this time of year, today was a good example. We start to get these gusts, as the sun comes up, because your mixing layer is deepening. And it's taking those gusts at the top of the mixed layer and bringing them right down to the surface in kind of this turbulent flow. So wind gusts can also be enhanced. I think many of you, who live or go into the cities have noticed this. It can be enhanced in your tall buildings. Think about going through downtown Boston, Providence, Hartford, or Midtown Manhattan. Fifth Avenue is a good example of that. The air is channeled between the buildings. Also in river valleys, the Connecticut River Valley with a southerly wind or a northerly wind, that brings increased wind speeds up and down the river valley, the Merrimack Valley too. So when you channel the wind, you're pushing that wind into a smaller space. So as a result, it has to speed up by simple physics. So as I mentioned, upper air soundings can show us how deep the mixing layer is and give us the potential for wind gusts. So on this example of a sounding, and again, just to orient everybody here, temperature is on the right. So this is temperature going up with height, and the left is dew point. So we look at the temperature, and we look for where it decreases with height and then stops and suddenly goes up. This is called your inversion height. So in this case, the inversion height is around 875 millibars on the left. That equals about 4,500 feet. And the strongest winds in this layer is about 30 knots here, which I've circled from the northeast. So that's telling you your gust potential is about 30 knots or 34 miles per hour. Now, if you want to mix some of these stronger winds above down, the air either has to warm up, so you steepen this curve, or it has to cool down aloft. And those are the two ways that you deepen the mixing layer. So think about in the spring. We're coming out of the winter season, but up in the atmosphere, it's still pretty cold. It's still, we're not into the warmer part of the year. So the atmosphere is kind of still in wintertime mode. But down to the ground, the sun's getting stronger. Our days are longer. There's better surface heating. So what we're doing during the day is we're warming the curve down here, and we're cooling the curve up here. So that's going to deepen our mixing height, sometimes up to 10,000 feet or 700 millibars. And that's when we can get our really big gusts going during the day. So again, that's primarily the March, early April timeframe is when we get our strongest winds. But even until, early to mid-May, these can continue depending on kind of the weather pattern. So when we forecast wind gusts, we look at forecast model soundings. And we've talked about a program called BuffKit that you can download for free and get data from there. But there's also on various websites, you can find model soundings. Here's an example. This was from, I believe, the January blizzard, but it kind of shows you the potential for wind gusts. So when we look at on BuffKit, you'll get two values when you look at the mixing. And the mixing height is shown at the top of this gray curve. You can see it starts to bump up. Very slight here for Plymouth and Nantucket. But it calculates the mixing layer for us. So the lower value is kind of the average wind gusts in this mixing layer. So it's a good guess. And then the higher value is kind of the maximum potential wind gusts. So in this particular situation, for Boston, we could expect gusts, maybe 35, 40 knots. So you're getting, that 40 to 50 mile per hour range. But there's the potential for a gust as high as 50 knots or almost 60 miles per hour. So that's one way we look at from forecasting. And you can go through these hour by hour throughout either a storm or whatever on a given day. But these are really very useful to show us the potential for mixing in that mixed layer. All right, so with that, let's take a look at some of the climate trends on wind, and we'll see if there's actually anything to it. So the theories are warming temperatures will lead to deeper mixing and therefore stronger winds. Climate change, whether we, agree or disagree on the human element or just natural cycles, will produce stronger storms, and that can result in stronger winds. So let's see if we can either, prove or kind of disprove these two theories. And what we're going to do is look at wind roses, which show the average wind speed for our long-term climate sites. So let's take a look first. What is a wind rose? If you're not familiar, this is a graph. It shows prevailing wind direction and speed over a given period of time. So on the left, you're looking at a wind rose for Nantucket, and this would be over the month of August. So from 1970 through 2021. So this shows us in August on Nantucket, the prevailing wind is from the southwest. So we're using compass points. The wind is blowing from the southwest a majority of the time. And think about it, that makes a lot of sense, right? We get in the summertime pattern, high pressure off the coast. We get into these warm and humid days where the wind is primarily out of the southwest for days on end. So notice also there's a little bit of wind from the northeast, but not quite as much. That could have to do with maybe an offshore low or even a tropical system, and out of the east as well, but not a lot of winds out of the western northwest. So that tells us our prevailing wind from Nantucket on August is out of the southwest. But by comparing different periods of time, we can also see if there's any trends of increasing wind speed. So we can look at certainly a 30, 40, 50-year period, but we can also break it down into smaller chunks to see if there's anything to it. So let's start with Boston. And again, we have to look at our long-term climate sites because this is where we have the longest stretch of data. So I've broken it down kind of in 20-year periods. We've got 1962 to 1982, and this is throughout the entire year. So notice the prevailing wind at Logan is out of the west or northwest most of the time. Some contribution out of the southwest and some contribution out of the east. So what are we looking at? Well, throughout the year, west and northwest flow. Think high pressure moving in, cold fronts moving through. Occasionally we got our southerly wind days ahead of them. We get our sea breeze days here, our nor'easters in the winter. That contributes to that. Is there anything to it? Well, the magnitude of the wind is the farther out it goes. So these are our strongest winds, and these are a little bit weaker. So is there anything to it? Well, eyeballing it, I would say maybe. It's kind of hard to tell, but you can see these west-northwest winds extend a little bit farther out on the graph. They're also a little bit more toward the west on both the 1982 graph and the 2002 period graph than it was for the original. Also, a lot more southerly flow. Look at this increase here over the past 20 years as opposed to the previous two. And look, even in the east, southeast flow, been quite a bit. So for Boston, yeah, there is a little something to it, especially when you talk about southerly winds, southwest winds, and east or southeast winds as well. So yeah, for Boston, I think there is a little bit of a trend that it's certainly been windier since the 1980s. All right, let's look at Hartford. And Hartford, being Windsor Locks, located in the river valley, it's going to have a predominant north-south flow. Again, we're looking at back to 1962. Note that, it's a little bit out of the northwest, primarily out of the south, a little bit out of the north. But notice this has increased from 1982, more southerly flow, more northwest flow. Well, maybe a little bit weaker there, but definitely a little bit more north-northeast flow. And as we look at the last 20 years, definitely a little bit more in the way of northwest flow across the board, a little more north flow, and definitely more south. So I think since 1982, you can also make the argument that winds have gotten, a little bit stronger. Maybe not as much of a signal as at Boston, but there's a little bit of a signal there as well for Hartford. Okay, Providence, another coastal site. Are we seeing a notable trend here? Yeah, I think so. It looks but there's a little bit of a difference in this one. Notice, we're starting with a prevailing northwest, maybe south-southeast flow, and this is more of the Providence sea breeze at this direction. Definitely more wind, 1980s, 1990s to 2002, kind of fanned out, in all directions. Definitely more out of the sea breeze direction here. And then as we look at the last 20 years, I think, still seeing that signal for the sea breeze. And again, for Providence, it's a sea breeze. There's two of them. Kind of this 160 to 180 sea breeze, and then this 200 to 210 sea breeze that occurs. So definitely a stronger sea breeze signal. Not as much as a northerly northeasterly signal over the past 20 years, but maybe a little more out of the west and northwest. So mixed signals here, but I see definitely more kind of in that sea breeze, the southerly direction. And just to round it out, Worcester, definitely more of a signal here, especially out of the west and northwest. You can see a kind of definitely an increase in events since the 1980s. A little bit more out of the southwest as well. Maybe not quite as much of a signal, but you see a little bit of a signal there out of the west and the northwest. So the summary on all of this, there does appear to be some increase in the wind speed over the years, especially at our coastal sites. But I would say more data, a longer time period is needed. Look at it, maybe go back a little bit more. But the increasing winds may be due to the climate change signal, some warmer temperatures, stronger storm systems. The sea breeze days would certainly argue to warmer temperatures. Is it normal variability or a combination of both? That's a really good question. That's probably where a climatologist would have to come in. But for the most part, as I mentioned, March, April, and May tend to be our windier months due to our warming spring temperatures and our colder air aloft. Remember, it's that mixed layer. How high it gets means how high the wind speeds can be. All right, so with that, I will pause here for part two. Let's see if we have a couple of comments, and then we'll get on to our weather briefing. From Sebastian, seems to me in the past few, I'm sorry, that was from before. Sorry, Sebastian. Here we go. From John, the upper air sounding shows several inversion points. Is this normal? Yeah, it actually is. We kind of focus on the low level inversion. But it's not uncommon at all to see different layers where the temperature jumps up a little bit with height. And really for when we talk about thunderstorms or mixing, we're looking at the low level. So think anything below 700 millibars, below 10,000 feet. But some of the upper layers come into play more with thunderstorms. They tend to be mixed out during the day, either due to warming at the surface or cooling aloft. But you can have several inversions throughout a given sounding. All right. So I don't see any other questions. If we'll go on to the weather briefing, but if you think of anything, feel free to throw it into the chat, and we can answer it later.